yeah, so this is continuation of second module itself. See, when the denominator like f of z divided by, so if it is in the form of z minus a whole power 1, so we use general, we use cauchys integral formula, but we have not used general formula. So when to use general formula means when we have a power, so in the place of n plus 1, so we made it as 1 and we solved many problems. So if in the place of n plus 1 more than 1, that means 2, 3, 4, in such cases, we should apply Cauchy's integral general formula. So this is the general formula. Once again, I'll read it. Integration C f of z divided by z minus a whole power n plus 1 dz is equal to 2 pi I divided by n factorial into f power n of a. So this one problem, we'll finish it now, and then we'll go for fourth module. So the question is like this. Number of question is 10. This I have shared the notes in your group. So evaluate integration C sin pi z square plus cos pi z square whole divided by z minus 1 whole square z minus 2 into dz. So it is not completed, where C is circle. We have cases. First case, modulus z is equal to 3. Second case, modulus z is equal to 1 by 2. Third case, modulus z is equal to 3 by 2. So for each case, we need to find. So this is the question. So first we'll solve it. See, first thing I'll tell. Here, what we have a question, sin pi z square plus cos pi z square divided by, we have factors. How many factors are there? See, there are 3 factors. Z minus 1 whole square, that means z minus 1 into z minus 1, and here z minus 2. So however, we need to split. So that is our first step. We need to split. So first we'll apply partial fraction. So how to apply partial fraction? See, consider 1 divided by this denominator, z minus 1 whole square into z minus 2. Very important point. And it is basic only. Now see, we have 2 denominator, that means z minus 1, 2 factor in the denominator. One factor is of whole square, another is z minus 2. So if you split it, it is 3. 3 only we'll take, 3 constants only we'll get. So no need to worry about that. One is z minus 1 whole square plus whole divided by z minus 2. So what I should write in the numerator? So that is important. See, it is a quadratic form. So what is quadratic form means? We all know a x square plus bx plus c. So this is a quadratic form. See, in the place of x, we have z minus 1. That means a into z minus 1 whole square plus b into z minus 1 plus c. So this is the quadratic form. A is nothing but 1, b is nothing but 0, c is nothing but 0. So like this, it's simple. Since it is quadratic, in the numerator, we'll write linear form, ax plus b. So in the place of x, what we have? Z minus 1. So it is a into z minus 1 plus b. So this is how we need to take. Plus, so already 2 constants we took. So one more constant is there, that is c. So c divided by z minus 2. So why we wrote here only constant means, see, here we have linear equation. So here it is. So here we have linear equation. So here it is constant. Here it is quadratic. So here it is linear. If it is cubic, here we'll write quadratic. So that is the order of splitting partial fraction. This is how we need to take partial fraction. So when I split for each and every term in the numerator, what we get? 1 divided by z minus 1 whole square into z minus 2 is equal to a divided by this z minus 1 get cancelled, a divided by z minus 1 plus b divided by, there is nothing to make cancel, so the denominator as it is, so z minus 1 whole square plus c divided by z minus 2. So this is how we got it. So now we need to multiply by this denominator. When you multiply by this denominator, what we'll get? So this numerator, this denominator get cancelled to give 1. So 1 is equal to a into this 1 there's z minus 1. So for each and every term, here, this factors we need to multiply. So when you do that, z minus 1 get cancelled. So a into z minus 1 into z minus 2 plus b into z minus 1 whole square. Z minus 1 whole square get cancelled to give z minus 2 plus c into z minus 2 get cancelled to give z minus 1 whole square. So we need to find constants, that is a, b, c. All the three constants we need to find. So see the common factor coefficient for any two constants, so that another constant we can able to find. So here also z minus 1 is there. Here also z minus 1 is there. Correct. Here also z minus 1. Here also z minus 1. So we can make this a coefficient and c coefficient as 0 by giving the value. So put z is equal to 1. So that what we'll get, 1 is equal to 0 into anything 0. So a coefficient is 0. So a also 0. A into 0 is 0. And c into 0 is 0. So both are eliminated to give b into what is 1 minus 2? 1 minus 2 is minus 1. So therefore b is equal to minus 1. So when you send minus 1 to other side, we'll get, when you multiply by minus 1 on both the sides, so b is equal to minus 1. So like this. Next, put like that common factor. So here z minus 2, here z minus 2. So for these two constants, we have common factor. So we can find c. So put z is equal to 2, that is 1 is equal to, this 2 will get cancelled, no? So c into 2 minus 1, 1 whole square. Therefore, just c is equal to 1. See, we have two methods now to find a. You can give z as 0 so that you can able to find, or you can equate the coefficient of z square. You can equate the coefficient of z square. So when you equate the coefficient of z square, there is no z square at all here. There is no z square, means 0 z square here, correct? And here z into z, when you multiply, definitely we'll get here z square. Okay. And here there is no z square. And here we have here z minus 1 whole square, a minus b whole square. So definitely we'll get z square. So here z square, here z square, here z square. So when you equate the coefficient of z square, what you will get? 0, correct? Coefficient, only for z square coefficient we are taking. So here also z square. So what is the coefficient for z square? A. And then here we have z minus 1 whole square. So z square will be there. So coefficient is c. And we know the value a plus c is 1. So this implies a is equal to minus 1. This implies a is equal to minus 1. So now we need to substitute these three values in this equation, correct? So before substituting in this equation, directly we can take this integration form, but in the numerator we have two terms. Since it is lengthy to write all the three constants, so for that what we'll do, let us consider f of z as sine. In the question it is there, sine pi z square plus cos pi z square. So we can take like this. So therefore, what happens for this term, this part? So integration, therefore integration c f of z divided by z minus 1 whole square into z minus 2 dz is equal to, integration we have taken, no? So with respect to z. And what is the value of a? A value is minus 1. So here it is minus integration c. The place of sin pi z, cos pi z. So we'll write just f of z divided by, what is the denominator we have? Z minus 1. So z minus 1 into dz. Next, second one, b. What is b value? Minus. So again minus integration c. Very important step it is. F of z divided by denominator what we have? Z minus 1 the whole square into dz. Next, c. C value is 1. So just plus integration C f of z dz divided by, what is the denominator we have? Z minus 2. Okay. So let us consider this as I. Okay. This above format I is equal to, you can take. So I is equal to this format. I is equal to, since we have three different terms, so let us take this one I1, this one I2, and this one I3. So let it as equation number 1. Okay. So like this we got a similar thing only, but the factors are different, so we followed this. Now our equation, we splitted our factors so that you can equate this each and every term to cauchys integral formula or cauchys integral general formula. Cauchys integral general formula. So here for which we'll use cauchys integral formula means, for this we'll use cauchys integral formula, and for this we'll use cauchys integral formula. Why means power is nothing but 1. But here it is 2, no? So definitely we need to apply cauchys integral general formula. So we'll go for case 1. So what is the case 1 we have? So case 1 is modulus z is equal to, the case 1, modulus z is equal to 3. Now the point, so this is there in our equation, the point A is equal to, now see when you compare with z minus A, so what you will get in the place of A? 1. And here also A, 1. And here in the place of A, we have 2. So A is equal to 1 and A is equal to 2 or less than 3, no? Less than 3. So since they are less than 3, lies inside the circle. So both the points A is equal to 1, A is equal to 2, which are less than 3, are lies inside the circle. So definitely we need to use cauchys integral formula and cauchys general formula. Okay, if it is outside, directly 0. So since it is inside, we need to apply it. So we'll go for first one, I1. So what is I1? Minus integration, see I1 is this, minus integration C f of z divided by z minus 1 into dz. Okay, so this is I1. So when you compare this, what you will get? Minus into 2 pi I into f of a, in the place of a, 1. So what is f of 1? We don't know. Minus 2 pi I into f of 1 we need to find now. So how to find f of 1 means, so here we have f of z. So let us find f of 1 separately. We know that f of z is equal to sin pi z square plus cos pi z square, and that is equal to f of 1. 1 means in the place of z 1, so it is sin pi plus cos pi. We all know sin pi is 0, cos pi is minus 1. So plus into minus minus. So 0 minus 1 is minus 1. So what is f of 1? Is minus 1. So minus into minus plus. So it is 2 pi I. So what is the value of I1? I1 value is 2 pi I. Next we'll go for I2. So what is I2? Minus integration C. Here we have minus integration C f of z divided by z minus 1 whole square into dz. So we need to compare with integration C f of z divided by z minus a whole power n plus 1 dz is equal to 2 pi I divided by n factorial into f power n of a. See, why we need to compare means because here power is more than 1. Okay. When the power is more than 1, this we need to take. So now, so what we'll get when you compare with this, when you compare this in the place of n plus 1, what we have 2. So this implies n is equal to, when you send 1 to other side, 2 minus 1, 2 minus 1 is 1. Okay. So when you do that, what we'll get for I2? I2 is equal to minus as it is. So this formula 2 pi I divided by n factorial, n is nothing but 1, 1 factorial f power 1 of a. So it is n of a, n is nothing but 1. So f dash of a is nothing but 1. So f dash of 1. So you don't know f dash of 1. So we'll find it separately. We know that f of z is equal to sine pi z square plus cos pi z square. But what about f dash of z? F dash of z means sign differentiation is cos. Correct? Sin differentiation is cos x, cos pi z square into, but it is not x, no other than x. Pi z square differentiation, pi into z square differentiation, 2z. Next, plus cos integration, cos differentiation is minus sign. So it is plus into minus, minus sin pi z square into pi z square differentiation, pi into 2z. So what is the common? 2 pi z is common. And remaining elements are cos pi z square minus sin pi z square. So this is f dash of z. What is f dash of 1? F dash of 1 is 2 pi into 1, comma, cos pi minus sin pi. Correct? Cos pi minus sin pi. So f dash of 1 is equal to, cos pi is nothing but minus 1. This is nothing but 0. So 2 pi into minus 1. So f dash of 1 is equal to minus 2 pi. Correct? So you can substitute in I2. So therefore I2 is equal to minus 2 pi I into minus 2 pi. So therefore I2 is equal to minus into minus plus 2 2s of 4, pi into pi square I. So this is nothing but I2. Okay. So I1 we got, I2 we got. We'll go for I3 now. So there is no space. So I'll turn the page. So I3 is I3 is equal to I3 is equal to integration C f of z divided by z minus 2 into dz. So here only power 1, so directly we can use. So since it is lying inside, 2 pi I into f of 2. So 2 pi I into, what is f of 2? Sin pi z square. So z is nothing but 2, 2 square is 4. So sin 4 pi plus cos 4 pi. Sin 4 pi is 0, cos 4 pi is 1. So it is 2 pi I of 0 plus 1. 0 plus 1 is 1. So it is just 2 pi I. So this is about I3. So substitute all these values in 1. So what is 1? I is equal to I1 plus I2 plus I3. So therefore I is equal to, what is I1? I1 is 2 pi I, I2 is 4 pi square I. So 2 pi I plus 4 pi square I plus 2 pi I. So 2 pi I plus 2 pi I is 4 pi I. Correct? So when you take it as common, 4 pi I, so what we will get? 1 plus I. So this is the value of I when modulus z is equal to 3. So this completes case 1. So we'll go for case 2.
Sir, 1 plus pi, sir.
Yeah, 1 plus pi. So this completes case 1. So we'll go for case 2. So what is case 2? We have modulus z is equal to 1 by 2. 1 by 2 is nothing but 0.5. So what is the points we have? The point a is equal to 1 and a is equal to 2. Correct? Same like this only. So we took this point. So same like that. A is equal to 1 and 2. So both are greater than 0.5. So greater than means outside. So therefore these lies outside the circle. So what we get, I1 is equal to I2 is equal to I3 is equal to 0. Therefore from 1 I is also 0 when modulus z is equal to 0.5. See, case 2 is completed, but case 1 so many steps we use. How it is completed means because these 2 points are lies outside the circle. Since it is greater than this point, they lie outside the circle. Since it is less than this point means it will be inside the circle. Since it is outside, directly we can take it as 0. So therefore, from equation 1, I is also 0 when modulus z is equal to 0.5. Okay, so this completes case 2. So we'll go for case 3. So modulus z is equal to 3 by 2. 3 by 2 is nothing but 1.5. So we have 2 points. The point A is equal to 1. The point A is equal to 2. So this 1 is less than 1.5, therefore lies inside. So this point is greater than 1.5, so lies outside. Outside means A is equal to 2 will get in I3. So here we have I3. So here only we are having 2. So for this point, no need to do. That will give 0. But I1 lies inside, no. Minus integration C f of z divided by z minus 1 into f of dz. So it is minus 2 pi I into f of 1. So it is minus 2 pi I. Already you know f of 1. What is f of 1? F of 1 is minus 1. So it is 2 pi I. So directly I1 value we can take there. So it is minus 1. So therefore I1 is equal to minus into minus plus 2 pi I. Okay. Next we'll go for I2. I2 they said inside. Already we found I2. Already we know I1 also. So when it is inside, what is I2? See, these steps you need to repeat. So when you repeat, what you get for I2? 4 pi square I. So same thing only here also will get 4 pi square I because lying inside. And then I3. I3 is easy. Why? Because what is I3? Integration C f of z divided by z minus 2 into dz. So it lies outside. Outside means I3 is equal to 0. Therefore, from equation 1, I is equal to I1. That is 2 pi I plus 4 pi square I plus 0. So therefore, I is equal to what is common? 2 pi I is common. Correct. So 1 plus 2 pi. So lies, sorry, this is the answer when modulus z is equal to 3 by 2. So this is your answer. So those who have any doubts on this problem, you can ask me. See students, when the power is more than 1, we need to apply general formula. So if you have any doubt on this problem, you can ask me. So those who have any doubts, they can ask. See, because of it is important, so only I have done, or else I would have started fourth module. Yeah. Stop the recording, man. See, and also one more thing I need to say. Madhu, stop the recording.